I'm looking at number 1 here, and when I see it, I notice that it's already in slope-intercept form. So when I see that, I just automatically start by making my table. Now when I make my table, I'm going to choose really easy numbers. Easy as 0, 1, and 2. When I do that, I then will replace the x in the equation with these x coordinates that we picked. So 3 times 0 is 3. 3 times 0 is 0, and then minus 3 is negative 3. And then I've got 3 times 1 is 3, minus 3, that's 0. And then I've got 2 times 3, that's 6, minus 3, and that is 3 as well. Now I've got these coordinates here, so 0, negative 3 that I can plot, 1, 0, and 2, 3. So I'm going to go over here to my graph. I'm going to 0, down 3, down there, 1, 0, and 2, 3. I then will just make my line. My line will go through all 3 of these points, and then I won't forget to add arrows on the end because there's infinite many solutions, and this line continues on forever. We're looking at number 2 now, or number 3. We threw out number 2. That was a poor question. And this is the same type of problem. See, we've already got it in slope-intercept form. So we can make a table again. Start off x and y. We then can simply just pick easy numbers again. 0, 1, 2. When I put 0 in for x, I get 0 plus 4, y equals 4. I can put in 1 in for where the x is, plus 4 equals y, to get y equals 3. And then if I look at 2 that we chose, I put in negative 2 plus 4 equals y. Negative 2 plus 4 is 2, that equals y. So then we've got 2, 2. I now have all these ordered pairs here. Just look at it that way. And then I can plot them. So 0, 4. It's going to be there. 1, 3. And 2, 2. I then can make another line from that. We'll go right through there, and then I won't forget to add my arrows. Excellent. Now 4 is a little different because this is a form I don't recognize. The first 2 we did were in slope-intercept form, so I'm going to work that way in putting this into that form by switching around some numbers like we did previously. And I'm going to start by subtracting 5x from both sides and subtracting 5x. Those cancel, and I get negative 1y equals 0. If I divide both sides by negative 1, I get y equals 0. Now, when I get to this point, I always sort of get confused. So I go back to my trusty old table. I pick 0, 1, and this time I'm going to pick 5 because just change it up. But I go back and I look at my equation right here that we found, and it says y equals 0. So I go to that y column and I put in 0 for every single one. So that way when I go to plot, I've got 0, 0 on here. I've got 1, 0, and I've got 5, 0. Now I can even throw on negative 1 or negative 2, negative 5. No matter what, it's always going to be on that x-axis. So when I go to make that line, it's just going to go right through the x-axis. Because any point on this axis, the y coordinate will always be 0. And then I'm not going to forget my arrows on the end.